Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 5 Learning Target 12 notes. So we're going to talk about quadratic applications. So we're going to look at word problems and how you know when you need to use each type of thing that we learned regarding quadratics. So the first thing we're going to look at is vertex word problems. So in vertex word problems, the word problems that reference finding a maximum or a minimum, you need to find the vertex. So maybe make a huge, large note to yourself that if you see the word maximum, if you see the word minimum, if you see the word maximize, minimize, anything to that extent, you have to use the vertex. Typically, the y coordinate is what's going to give us what we want. So the word problems on your homework are going to be really similar to these problems. So I really suggest having your note sheet out while you do this. Okay, so let's take a look at this. So the path that a skateboarder follows during his jump is given by that quadratic there. Okay, it's the horizontal distance x is the horizontal distance in feet. Y is the height in feet. What is the maximum height of the rider? Maximum. Okay, I need the vertex. Okay, so because I need the vertex, that's where I'm going to use that formula, x is equal to opposite of b over 2a. So let's assign our a, our b, and our c. So our a is equal to negative 0.5, our b is equal to 5, and our c is equal to 8. So let's go ahead and let's calculate out that vertex. So x is equal to opposite of b over 2a. So when you type that in, you get negative 5 divided by negative 1, so you end up with 5. Now remember that x represents the horizontal distance in feet. So 5 feet horizontally after the skateboarder jumps, it reaches the maximum height. But that doesn't answer the question. The question asks, what is the maximum height? So in order to get that, we have to solve for y. So I'm going to take this 5 right here, and I'm going to plug it in wherever I see an x in that original problem. So I have negative 0.5. Now I'm going to take that 5 and square it. So wherever I see an x, I'm substituting in a 5. So negative 0.5 times 5 squared plus 5 times 5 plus 8. So we're plugging that into our calculators exactly like it's written. Remember, the better calculator you have, the easier it will be. And when you do that, you end up getting 20.5 feet. So the maximum height of the rider is 20.5 feet. So the hardest part about these, first and foremost, is remembering to label. And then once you remember to label, also figuring out whether you need the x or the y coordinate to answer the question. Next, taking a look at this next one. First of all, it says minimize costs in bold. So before I even get started, I know I have to use my vertex. So it says we want to find the maximum the minimum cost, because we're minimizing the cost. So here's our quadratic. I know I need to find my vertex, and that's what step A asks us. So A is 0.25, B is negative 12, and C is 200. So let's go ahead and plug that into our formula. So x is equal to the opposite of b, so that b is going to become positive, over 2a. So that's going to be 12 divided by 0.5, which is going to give me 24. So the x coordinate of my vertex is 24. So wherever I see an x in this original equation, I'm going to plug that in to get what my y is, because all part A is asking is for that vertex. So I'm removing x and I'm putting in 24 wherever I see an x. And when you plug that in, you end up getting 56. So my vertex is 24. 56. Now, what do these magical numbers tell me? When we're talking about the minimum cost itself, that comes from the y coordinate of the vertex. The cost itself is always the y coordinate because the y is modeling that cost function. So that means that our minimum cost is going to be $56. How many cars do I need to work on? Well, our x's are what lead to that minimum cost. So the minimum number of cars that need to be worked on are 24 cars. Okay, so that's how you answer that one. The hardest part is labeling it and figuring out where each of those need to go. So let's take a look at a couple more problems. So in quadratic word problems, in problems that reference to how long it takes an object to hit the ground, we use the quadratic formula and ignore any negative solutions. So whenever it says, when will it hit the ground? After how long will it hit the ground? Those always use the quadratic formula. So those right there are the keywords you need to look for. If we have negative solution, no one's invented time travel yet, okay? Negative solutions don't make sense. We just throw those out. So let's take a look at number 3. An object is launched 19 meters per second from a 70.8 meter tall platform. The equation is given here. Don't let these extra numbers that they threw in throw you off because they included them in that equation right there. Also, the s of t, that's really the same thing as if there was a y there. So this is asking, when does the object hit the ground? Well, s of t represents how high we are off the ground. Well, think about it. If I'm on the ground, how high off the ground am I? Well, I'm off the high 0. Okay, if I'm on the ground, I'm 0 meters off the ground. So now we're going to take this quadratic that was given to us and set it equal to 0. If you're ever given a quadratic and asked when does something hit the ground, you just set it equal to 0. That's all you have to do. So now we're going to use the quadratic formula. So to do that, we need to sign our a, which is negative 4.9, our b, which is 19.6, and our c, which is 70.8. And now we're going to go ahead and plug this into the quadratic formula. So we get our t, because we're using t for time, is equal to the opposite of b plus or minus the square root. Don't let the decimals confuse you. You're still plugging it the same way, and you're still putting parentheses around everything. Minus 4 times a times c. All of that over 2 times a. So now, remember when you're doing the quadratic formula, the first thing you want to do is simplify what's underneath the radical there. So you get negative 19.6 plus or minus the square root of 19.6 squared minus 4 times negative 4.9 times 70.6. And when you plug that into your calculator, 70.8, you get 1171.84. Try and avoid rounding early if you can. Wait till the very end round. Divided by 2 times negative 4.9 is negative 9.8. So now we need to create our two versions. So first I'm going to write out my positive version. So I have negative 19.6 plus the square root of 1171.84. Then you're going to hit enter. Once you've hit an enter, you're going to take and you're divided by negative 9.8. So you're going to take that enter divided by negative 9.8 and you're given negative 2.295. Those are three numbers you're given after that. Well, we want to take a look at the third number. So the third number is 5 or greater, so we need to round up. Well, when we round 9 up, we actually have to round the 3 up. So we're left with negative 2.30. Well, it's a negative answer, so we have to throw this answer out. It's not going to work for us. Let's check our minus version. Negative 19.6 minus the square root of 1171.81 divided by negative 9.8. So when you type that into your calculator, you end up getting 5.493. Well, 3 is less than 5, so we're going to keep that 9 the same. So we end up getting 5.49 when we round, and we want to label that seconds because it was given to us that t was in seconds. So this is our final answer. We threw one of our solutions out, and our next answer was 5.49 seconds. Let's take a look at this last problem. So we're launching an object 64 feet from platform 80 feet high. When will it reach the ground? Okay, when it reaches the ground, the height, which in this case is represented by h of t, is going to be 0. Remember, whenever it's asking you about something hitting the ground, you're just going to take and set the equation equal to 0. So now what we're going to do is we are going to plug this into the quadratic formula. So our a is negative 16, our b is 64, and our c is 80. So we're going to get opposite of b plus or minus the square root of b squared minus 4 times our a times our c, all of that over 2 times our a. So now what we want to do right now is we want to simplify underneath the radical first. So we're going to simplify underneath the radical. And when you do that, you end up getting 9216 divided by negative 32. So now we're going to split it up into our two versions. So first I'm going to do my positive version. So I have negative 64 and I'm going to do plus the square root of 9216. Then I hit enter and divided by negative 32. When I do that, I get negative 1. I don't want a negative answer. I have to throw that one out. Let's try this next one. Negative 64 minus the square root of 9261. Then you're going to hit enter and divide it by negative 32. When you do that, you get 4.91. Okay, and then we're going to label it. Oops, sorry, let's take a look at the rounding on that one before we do the answer. So when you plug it in your calculator, the 3 decimals you get is 0.4906. Well, if you got the third number, that's 5 or greater, so we need to take this number and round it up. So we get 0.491. And we want to label it seconds because it gives us that T represents seconds. So that object is going to hit the ground after 4.91 seconds. Again, this note sheet will really help you on your homework sheet, so make sure you have it available to you. So that concludes your note video today, and thanks for listening.